Today we'll learn about the zeros of a quadratic polynomial. We know that quadratic polynomial can be represented as px is equal to ax square plus bx plus c. And in order to understand the zeros of a quadratic polynomial, we should look at the graph of this quadratic polynomial. So the graph of a quadratic polynomial is a curve. So it looks something like this. So if we look at this curve, it is intersecting the x-axis at two different points, x1 and x2. At both these points, the value of the curve is 0. So x1 and x2 are called as the zeros of the polynomial or zeros of the quadratic equation. Now this is just one example of the curve of the quadratic polynomial. There could be other forms of the graph. So for example, the graph could look something like this. Now if you carefully look at this graph is intersecting the x-axis at just one point, x1. So x1 is also the zero of the polynomial, and in this case there is just one zero, whereas in the earlier case there were two zeros. Let's look at another example of this graph. So the graph could look something like this. If you look at this graph is not intersecting the x-axis at all. So there are no zeros in this scenario. Or we also call as there are no real roots of this quadratic polynomial. So by looking at the quadratic polynomial, how can we tell whether there would be two zeros or there would be one zero or no zeros at all? So let's learn about an approach using which we can tell how we can determine whether there would be two zeros, one zero or no zeros. If you carefully look at all these three graphs and you look at the vertex of these three graphs, so in this scenario this is the vertex, and in this second scenario this is the vertex, and in the third scenario this is the vertex here. If you look at the vertex in the first graph, this vertex is lying below the x-axis. So if the vertex is below the x-axis, in that scenario we would have two zeros. Whereas if the vertex is touching the x-axis, then there would be just one zero. Whereas if the vertex is above the x-axis, then there would be no zeros. So if we find the vertex of a quadratic graph, we can tell how many zeros it would have. Now how do we identify the vertex of a quadratic polynomial? So for that we have to write the quadratic polynomial in a vertex form. So the vertex form of the quadratic polynomial is written as a into x minus h square plus k. So this is called as the vertex form of the quadratic polynomial, and here h and k represents the coordinates of the vertex. So if the graph is like this, then this point here is represented by h and k. So let's try to go through some examples and understand how we can write a quadratic polynomial in the vertex form so that we can determine the roots of a quadratic polynomial. So let's take an example. So x square plus 4x plus 6. Now this quadratic polynomial is written in its standard form. Let's try to write this quadratic polynomial in a vertex form. So we'll try to write this as x square plus 4x. Now what I want to do is I want to make this as a whole square, x plus something whole square. So I would try to use the formula of x plus a whole square. So in order to do that, I need to take the half of this middle term here, which is 2, and I'll write the square of that middle term here. And then since I'm adding something, I need to subtract the same number in order to maintain the equation. So now this whole term here, x square plus 4x plus 4, would become x plus 2 whole square plus 6 minus 4 is 2. Now this equation, if you look at it, this has become a form of a vertex form. So x minus h square plus k. So in this equation, a is equal to 1, h is equal to, so if you look at the sign here, in this standard form we have minus h, whereas here we have plus 2. So the h would become minus 2 and k is equal to 2. So now the coordinates of the graph, if you try to plot this vertex here, so the vertex would be minus 2 and 2. So it would be something here which is minus 2 and this is 2. So the vertex would be something somewhere here. So the graph would look like this. So now clearly the vertex is lying above the x-axis. So this quadratic polynomial is not going to have any real roots. So it will have no zeros. So this way, by writing the quadratic polynomial in a vertex form, we can quickly determine how many roots would it have. Let's take another example. Let's say our quadratic equation is x square minus 6x minus 7. So let's try to write this quadratic equation in the form of a vertex form. So we'll write this as x square minus 6x. Now let's look at this middle term here, the coefficient of the middle term, which is 6, and we'll try to take the square of the half of this middle term. So half of this middle term is 3. So we'll take the square of this middle term, which is 3 square is 9. So we'll try to add 9 here. And then since we have added 9, we need to subtract 9 as well to keep the equation. So we'll subtract 9 here as well. So this would become, this whole expression here would become x minus 3 square. And here minus 7 minus 9 would become minus 16. So now we have written this in the form of a vertex form. So the vertex form, as we remember, it is a into x minus h square plus k. So let's try to find the values of a, h and k. So a is equal to 1, h is equal to 3, and then k is equal to minus 16 here. So let's try to plot the coordinates of the vertex here in the graph. So if the graph is like this, so h is 3, so h would be somewhere here, and then k is minus 16, so minus 16 would be slightly down below here. So this would be minus 16. So we would have this 3 and minus 16 here. And since this vertex is lying below the x-axis, it's going to intersect the x-axis. So we know that this quadratic equation is going to have 2 real roots. Now let's try to find the values of these 2 real roots. So I'm going to delete this graph here, and let's get back to our quadratic equation. So now we have the quadratic equation x minus 3 square minus 16. Let's try to write this in the form of a square minus b square, because this is going to help us find the roots of the quadratic equation. So it would look like x minus 3 square, and we know that 16 can be written as 4 square, so we can write it as x minus 3 square minus 4 square, and we know that a square minus b square is equal to a plus b into a minus b. So we can write the expression here as x minus 3 plus 4 and x minus 3 minus 4. So this becomes x minus 3 plus 4 is plus 1, and this would become minus 3 minus 4 would become minus 7. So now we have found two factors of this quadratic polynomial, and we know that in order to find the roots of the polynomial, we need to put each of these factors equal to 0. So if we put x plus 1 is equal to 0, it would give us x is equal to minus 1. And similarly, if we put x minus 7 equal to 0, this would give us x is equal to 7. So minus 1 and 7 are the two zeros. So this way we can find the roots of the polynomial as well using the vertex form. Thank you.